Alright, here we are. Oh my goodness, this is getting more complicated every time I look. Anyways, we're given this sort of three-part log expression. Already I can see I'm probably going to be doing some funky things with my difference property or my quotient property for logs here. These are all log base 3. Now one thing that has to be true is that x minus 1 has to be greater than 0 because I can't take the log of anything that's negative. X squared has to be greater than 0, and that's no big deal. X squared is always bigger than 0. And x plus 3 also has to be greater than 0. And so I can see that x has to be greater than 1. It also has to be greater than negative 3, but if it's greater than 1, then it's already greater than negative 3. Okay, so first thing we're going to do is we're going to go log base 3 of x minus 1 is equal to log base 3, and look, because this is the difference of two logs, I can turn it into the log of a quotient, x squared over x plus 3. Okay, now since these two logs are equivalent, this is one of those rare opportunities where I can say the arguments have to be equivalent since the logs are equivalent. And so x minus 1 is equal to x squared over x plus 3. Woo! That was easy. Okay, now for the slightly harder part, we have to sort of gather, simplify, solve. What I'm going to do to get rid of this x plus 3 on the bottom, because fractions make everybody nervous, I'm going to multiply both sides by x plus 3, and of course when I do the expansion I wind up with x squared minus x plus 3x or plus 2x minus 3 is equal to x squared, which ever so fortunately the x squareds disappear because I really don't want to solve a quadratic equation today, and so that when I subtract x squared from both sides it's all going to disappear. And so 2x minus 3 is equal to 0, and so 2x is equal to 3, so x is equal to 3 halves. So there we go. The good news is 3 halves is greater than 1, and so we have solved this logarithmic equation for x.